Welcome. In this lecture, I want to talk about these different kinds of functions, injective, surjective, bijective functions. And the reasons why it's good to know what they are and to know which functions satisfy them and so on is because there are certain times that you actually need for a function to be injective, surjective, or bijective in order to do something. So you can only do things in those circumstances with those functions. For example, taking a function inverse. Okay, so let's just kind of jump into, I'm going to get, like, my descriptions of them are not going to be as technical as you might get in a proper pure mathematics course or something like this, but they should be enough so that you kind of understand what they are. And so injective functions. Okay. So what happens with injective functions is if you have distinct inputs, so if you have two different inputs, then your function, when you stick those two distinct inputs into your function, then what you should get out will have to be distinct outputs. Okay, so you don't stick two different things in and get the same thing out, right? So what is an example of not injective, which is kind of easier in some sense to notice? So is one where you're going to have, so this is going to be tested via, and then I'll show you what the example is, so it's easiest to see that it's not injective. Okay, so this is tested via the horizontal line test. Okay, and that should kind of make sense because, so let me show you what's going on here. So you have your axes, so you have your x-axis and your y-axis. In fact, let's put, because this is actually my domain, my inputs, and then my output's my y. Okay, and we're going to look at the function y. So we have y equals f of x equals x squared. Oops, how did I do that? We want it to go through there, just like that. Okay, so this is, I'm just going to clean that up a little bit so that it's clear what we've got going on there. Okay, so we have, this is a graph of y equals f of x, which in this circumstance is going to be x squared. Now what happens with this, and this is why this is going to violate the horizontal line test, so we end up having, it's possible, so the horizontal line test is, it's possible to draw a horizontal line, which is going to intersect the graph in two places. And why does this violate injectivity? Because what's happening here is I have these two values, -2, for example, and 2, if that's, like this is that are giving me the same output value 4. Okay, so f of x equals x squared is not injective, since -2 and 2 have the same output 4. Right, as in if I want to square, so I want to put it into this function, so f of x, or so f of -2 equals -2 squared equals 4 equals 2 squared, which is f of 2. Okay, so this violates. On the other hand, if I had, so if we can draw here, I mean that bigger than one might have hoped in life. This one's easier to draw, so we can make it a little bit smaller here, and it's okay. So we have my x-axis and my y-axis again. And if now I'm going to draw f of x equals 2x plus 1. In this circumstance, no matter what horizontal line I draw, right, I'm only going to hit the graph once. Okay, so on the other hand, f of x equals 2x plus 1 is injective because no horizontal line hits the graph twice. So since no horizontal line hits the graph twice. Okay, now what about surjective functions? So surjective functions. So for these, we have the image equals the codomain. So we had that the image equals the codomain. I know this is a bit of reuse of colors, but now this is more consistent with what we had before. Okay, i.e., everything in the codomain is an output. So everything in the codomain is an output. Okay, so let's kind of look at then what we end up with. So the first example is that if I take f from the real numbers to the real numbers defined by x goes to x squared. Okay, so I'm looking at the same graph of this function over here. Okay, then you're going to notice that while some of these lines are hitting twice, it's possible to draw horizontal lines that don't hit at all. Okay, so there are some outputs that don't actually occur. Okay, so this is not surjective. Right, because well, we could have that -1 is a real number, so it's in here. So I'm just going to add in our colors. Right, so -1 is in the codomain because -1 is contained in this codomain R. Okay, like there. But we're going to have that. So, and -1 cannot be an output. So, and the same -1 cannot be an output. Right? How do we know it's not an output? Because when you square things, you get something non-negative, right? Because all outputs are negative. Okay. On the other hand, looking at the other function that we talked about here, so we had that, again, we have, so f is going from the real numbers to the real numbers, and here now it's going to be defined by x, right? So we have an x in here, and it's going to go to a 2x plus 1. So this is surjective. So this is surjective because, right, to get an, whichever output I want, y and r, so to get the output y and r, whatever this is, so whatever y and r I'm interested in, how would I get the input that gives me that output? Well, I can just kind of work backwards. So to get this, I'm going to take, well, now let's just solve. Okay, so we're going to go y equals 2x plus 1. It's going to happen precisely when we have y minus 1 equals 2x, which is going to happen precisely when we have y minus 1 divided by 2 equals x. Okay, so we're going to take, so we're just going to input. So we just input x equals y minus 1 over 2, and then we would get this output y. So no matter what the output is, we know how to get the input. So that's going to tell us it's surjective. And then when we're going to put these two things together, so finally, a bijective function is just one where it's both injective and surjective. So bijective functions they're ones where they're both injective and surjective. Okay, so it has to satisfy both. Okay, so for example, we have this function, we use the same function here, and we were able to see that's both injective and surjective. So we have the function f of x equals 2x plus 1. We knew that it was injective because it passed the horizontal line test, and no matter which horizontal line you chose, you never, well, you always got precisely one output. You only intersected once. You never intersected more than once. And then it was surjective, and you could kind of work backwards to find the input that you'd want to get whichever output you want. Or you could kind of see that no matter where I put the horizontal line, I do hit it once. I do hit the graph once. Okay, so I hope that made a little sense, and I will see you in the next lecture.